Hi everyone, I'm Siqi from Purdue University. Today I will present our work, Out of Control Effects of Multimodal Self-Similarity on Embodiment during Autonomous Avatar Demonstrations in Virtual Reality. The title slide shows a participant in VR facing a self-like avatar across a table in a virtual room. This work asks a simple yet important question. When users must give up control to watch an avatar demonstrate a task, can self-similarity in appearance and voice help preserve embodiment? This matters because many VR training and rehabilitation systems need autonomous avatar demonstrations. At the same time, embodiment is usually strongest when users directly control the avatar. That creates a clear design tension. In this work, we examine whether multimodal self-similarity can preserve embodiment when control is constrained. Prior work gives us three useful starting points. First, avatar personalization and active control have both been shown to increase embodiment and self-identification. And second, observational learning in VR can support motor skill transfer. Third, personalized avatars may maintain a degree of illusory agency even when motion is not fully controllable. Building on that literature, we focus on a case that is common in training but still underexplored: autonomous demonstrations with a self-similar avatar. Our objective was therefore to investigate how multimodal self-similarity in appearance and voice, together with avatar autonomy, influences embodiment, user experience, and behavioral responses during task performance in VR. In our user study, we used a 2x2 within group design with 24 participants. The first factor was self-similarity, comparing self-similar versus non-self-similar appearance and voice. The second factor was autonomy, comparing autonomous versus non-autonomous behavior. Across these four conditions, we examined three outcome groups: embodiment, user experience, and behavioral responses. Participants completed a block assembling task in a semi-realistic virtual living room. The workspace included 9 wooden blocks, a board, and a reference model. We also placed a virtual mirror in front of workstation so participants could observe the avatar during the task. On the slide, you can see the virtual living room, a top-down view of the room layout, and a close-up of the block assembly workspace. Importantly, participants stay in the first-person perspective throughout the study. In the non-autonomous conditions, they directly control the avatar. In the autonomous conditions, the avatar completed the task on its own, while participants observed the movement. For self-similar avatars, we generated appearance from participant photographs and generated self-similar speech from participant voice recordings. For non-self-similar avatars, we used sex-matched generic characters and pre-selected voice models. We also used a two-phase sanity check with both the participants and the research team. This figure summarizes the pipeline. We start from participant photo and recorded audio, generate the avatar and speech, review and adjusted them, run sanity checks, and then imported them into a VR application. This slide shows four conditions as a 2x2 grid. The top row shows non-self-similar avatars. The bottom row shows self-similar avatars. The left column is non-autonomous, and the right column is autonomous. So the participant either control the avatar directly or observe it, performing the task autonomously. This design allowed us to isolate the effects of self-similarity and autonomy across same task context. Next, I will show a short video clip of some of our study conditions.
We will walk through recordings that demonstrate what participants experienced in each of the four conditions.
Second piece, you're next to the first one.
Here, the avatar is fully controlled by the participant's movements.
Piece 4, let's see where you fit.
Here, the avatar moves and speaks on its own. The participant is only observing.
Halfway there, it's going well.
This is starting to look like a castle now.
Here, the self-similar avatar is fully controlled by the participant.
Only 2 left. I'm almost done. Last one.
Here, the self-similar avatar moves and speaks on its own.
We collected both subjective and behavioral measures. For embodiment, we measured body ownership, agency and motor control, location of the body, and external appearance ratings. For user experience, we measured presence, emotional reactivity, frustration, and self-attribution. For behavior, we tracked head directions as a proxy for gaze. And next, I will walk through the results from our study. Starting with self-similarity, we found it supported several key perceptual outcomes. On the right is the full self-report results table, and the red boxes mark the significant self-similarity effects I'm summarizing here. Self-similar conditions produced higher ratings for location of the body, external appearance, presence, and self-attribution. So even when users are not controlling the avatar, self-similarity still supported how closely the avatar felt connected to the self. Looking at autonomy, non-autonomous avatars improved control-related experience. Again, the table on the right shows the full self-reported results, and the highlighted cell marked significant autonomy effects discussed on this slide. Participants reported higher agency and motor control, higher presence, high external appearance ratings, and higher self-attribution when they directly controlled the avatar. This pattern is consistent with the idea that direct control remains central to several dimensions of embodiment. At the same time, autonomy increased emotional reactivity and frustration. The highlighted part of the table on the right marks the significant effects for emotional reactivity and frustration. In other words, when participants watched their avatar act on its own, the experience became more emotionally charged and more frustrating. So autonomous demonstration may be useful, but it also comes with a clear trade-off in user experience. Our behavioral results show that head orientation also shifted with autonomy and self-similarity. Autonomous and self-similar conditions increased mirror-directed head orientation. Non-autonomous conditions increased head orientation towards body, environment, and task. We also observed significant interaction effect for task-related head orientation, with greater task focus for non-self-similar autonomous avatars. These findings suggest that self-similar appearance and voice can preserve aspects of embodiment during autonomous phases. At the same time, across our self-report measures, autonomy and self-similarity showed mostly separate patterns of influence in the study. That means they can be treated as two design levers in mixed control VR. Our behavioral results also suggest that head direction patterns may help future systems adaptively balance demonstration and interaction. To conclude, multimodal self-similarity can buffer embodiment loss during autonomous avatar demonstrations in VR. It does not remove the cost of losing control, but it can preserve important aspects of self-relevance and embodied experience. For future work, we want to make multimodal personalization more accessible, integrate more real-time voice and movement autonomy, and examine these effects with eye tracking across a wider range of tasks. Thank you very much for listening.